Hello again, everyone. Welcome to lecture something. I hope you enjoyed Amy's lecture last time. Was it good? Useful? I think that stuff's useful. Like, try and get as much out of that stuff as you can. You'll have a few more. Same, hassle me and Andy as well, because we're outside. If you want to get an idea of what it's like on the outside, it's a good idea to get it early. See if you're doing the wrong thing. See if you want to run away or what sort of area you could steer towards. Yeah, I thought that was great, Amy's lecture. So we're week 4, you get 3 more lectures from me, and then we switch over to Andy for module 4. And homework is due at that point. So I'm sort of cognizant that your homework's coming up. So like, if you want to burn a bit of time in the lectures talking through some stuff, just grab me in the middle. If there's like a common thread or something I can jump to in the lecture, let me know. I'm happy to do that. Yeah, any questions about that? Good? Good. Okay, I'm good. All right, so same as always, some tiny review of what we did before. So this one's a bit of a monster and we're kind of at the end. Belaboring bubble sort, just to get you thinking about scaling of algorithms, look at built-in sort, data structures, dictionaries, sets. They'll come back again, don't worry. Priority queue based on a heap. That's an idea, like this ties directly to data structures, where directly to sorting, data structures and sorting together. So use a nice little data structure called this thing called a heap, and you can make sorting very, very easy. This thing's going to come up again and again, that asymptotics are not the whole story. So you do these analyses that say, here's your runtime, actual details matter. And sometimes the worst thing is better. The theoretically worst thing ends up being better. I was getting a question about the homework question 15, and that's kind of meant to be an example of that as a hint about how to think about the analysis of that. We'll come back to that though later when we get up to section 3. So yeah, we'll talk about that a lot more in section 3. So I went super quickly through this one, hopefully not too quickly, but I think it's in your homework, and this is like, there's a million tutorials on the internet. It's basically merge sort. The idea is you recursively go into the array and then you sort them on the way out. By doing that, you do less comparisons than you have to do with bubble sort. Hopefully that's clear. Quicksort's basically the same idea, except playing games with pointers, where you do array stuff. So then we started getting on to more practical stuff, which is we'll spend a lot of the time today on. Again, if you have specific questions about this stuff, because I'll just ramble on about Git and Unix and editors. But if you have specific questions, please feel free to target it a bit. Like, please do ask questions if you want anything specific. Can try and do some live demos using Git and stuff. But yeah, I guess I had a question last time, which was like, how should you guys be using Git? I think very simply is the answer. Like, hopefully I'll reiterate that today. The usual, like this is this problem when you're reading stuff, you've got the best practice in software, which isn't necessarily what you want to do as an individual, or working in a team, like a small team. You can get away with being pretty dirty and using it in a simple-minded way. I don't mind that. You got to make your life easy. As you develop and get more fluency with the tools, you start doing more sophisticated things. Cool. So we were starting with Git, and so I'm out of sequence, so I'll have to jump around a bit. So I want to reiterate the design goals, because this is how, as a boring professional software engineer, you kind of think about, what do I put into this thing and what am I going to get out of it? What functionality do I want from this bit of software? Internal details are for later. I'll sort that out eventually. I just really want to think about, like, how am I going to use this thing? And as I said last time, the main use case is this problem you have where you're going like versioning, where you can do this by names of files. Everyone's done it for essays and things in high school. You go version 1, version 2, version 1.2.1, and then you realize version 2.1 is bad. And you go back to version 1 and go version 1 final. It's basically all Git's doing for you. It's doing this by cryptography, by hashes. Doesn't matter that it's a cryptographic hash. That's just a detail of the implementation. But really, it's about keeping track of changes over time. And so you can jump from any point in history to any other point in history. So everything's there. So you want to be able to keep track, and you want to be able to go back in time, and you want to be able to do experiments. So big thing with software, and you would have noticed this with your homework, is I try to think, and now everything's, I won't say that, everything's broken really badly. It doesn't work anymore. And this is normal, and it's to be encouraged. Like, you should be experimenting when you're doing software. It's good to try things. Like, so you got some question in the homework, and you're going to go, I'm going to try and make this really, really fast. And then all of a sudden it doesn't do what it's supposed to do at all, but it is fast. Like, that's normal. So what you want to be able to do is do experimental functionality without disrupting the main thread. So that's a really big part of it. And it's one of these ones that the gotchas of it, like keeping track of branches and keeping track of where you're up to is a big deal. I think it's actually a flaw with Git. And this is one of the ways people use it versus how you can use it. Just say a little bit like that when we get up to it. You want to be able to keep a remote. So my computer falls in the sink, it's wet, it's gone, hard drive's ruined. It's nice to have a remote backup, case of a disaster, and to share. And you want to be able to work with other people, share code. This is not an easy set of goals to hit. And I was going to say about Unix first and then Git second. Git is a good example of a bad design, I would say, for users. It's hard to use. Like, all of you should have noticed that by now, that the learning curve is kind of steep and it's not great for users. So there's a whole bunch of stuff over the top of Git. There's a whole ecosystem of things trying to make Git friendly. And one of those is GitHub. So Git, very separate to GitHub. GitHub is like a service running Git in the background and there for sharing things. You also got GitLab, which is the Ukrainian version of GitHub. GitHub is owned by Microsoft now. It wasn't originally, but Microsoft are keen to get into that area these days, so it's kind of interesting. There's also GUI tools. Git itself is a command line tool, so that's a little bit of a learning curve if you're not used to command line tools, but hopefully after this course, you'll be, if you haven't used them, you'll be less scared of them. It's just keeping a mental model in your head of what's going on. Everyone has a cheat sheet for Git. Everybody. I am an internet-assisted software developer. If I did not have a cheat sheet for Git or for things like this, I would forget everything. Don't feel bad if you don't remember everything, because I definitely don't. You'll always end up working at a place and there'll be one Git expert who everyone goes and hassles when things go very badly wrong. That's kind of normal. It's really useful to have a look at this. So one of the things when you're using GitHub is it will provide automation around some of these things that you'll do, which can make your life easier. Git, in terms of being not super user-friendly, ends up looking like a bunch of magic spells sometimes. Like, if you're going to delete a branch locally versus delete a branch remotely, they're very, very different commands. And you go, I don't know why that is. It's kind of strange. You get all these strange things. But the basics are, I'll just go through these, git and init. So this is if you want to start a new code repository. Code repository is just a bunch of source code lying around, ideally just the source code. You shouldn't be adding things like data to it. I know in your homework you're doing that, which is a bit, but it's okay. Usually you don't want to put that stuff in your Git repo for the reasons I mentioned last time about how Git works. I don't know if you remember this. Git works on diffs between text files. So Git tracks line by line through a file and goes like, what actually changed about this file? And that's to make the Git repository smaller. It's more efficient to store differences when it's a human typing on a computer. If you think like the first big bit of code you write, it's going to be this big, massive thing. And then later on, you're only going to make small changes to it. That's the pattern. So actually storing the deltas between changes is a really good idea for efficiency. If you put binary data into Git, all bets are off. Small change, if you're interpreting this binary data file as a text file, you're going to get really massive differences. Basically, any small change to that file will make your Git repository huge. So that's a practical detail. So there's other tools for storing binary data. Okay, would have shown you git clone. Git config is a super useful one. Hopefully you're all set up with that stuff. git add, git commit, git status, git log, git diff. They're kind of the basics. If you're using Git on your computer, git clone is the main one that's talking about remotely. So you're going to point to somewhere remote. It doesn't have to be remote. It can be on your local machine too. But usual path is that you're going to go to one of these things on GitHub, click the little clone button, download button, git clone in your repository. Okay, cool. That's pretty straightforward. Last time I was deleting things from everything from this repository, just to show you that you don't need to worry too much. I'll show you a little workflow through Git on another one. I'll just show you examples here though. So last time, if I go ls, listing the current directory, just because I haven't done any Unix stuff yet, cd markdown, go to the markdown directory, ls, you'll notice that lecture unit 2 is missing. I deleted it like a madman. So what's going on? So that's fine. That's what Git's for. You shouldn't be scared of deleting things, editing things, changing things. If I do git status, so just context again, if you can't remember from last week, it's a long time ago. The lecture notes for this course are a Git repository. We do work on them. I have a remote copy here. This is just, so I just have a copy of this on my computer. None of the changes from this computer have propagated out. So git status. Okay, you'll see I'm on branch, Paul's test branch. It's up to date with origin Paul's test branch, and it's got this thing that's deleted. So nothing's actually changed yet. So I've deleted it I've deleted the file, but Git's tracked the changes and it said, actually, you've deleted this lecture unit 2. If I go, oh, that's a mistake, it even tells you what to do. You can go git restore file, lecture unit 2, .jmd. Nothing. It's all gone back. And if I look in the file, hey, it's back. So that's the whole file level. You can delete, rename files, add files. I can bit of Unix stuff. I'm going to put hello as a string into a file called hello.txt. And you'll see in here, there's a little thing called hello.txt. If I look inside this file, the cat hello.txt, say hello. I've just made a little file. Again, if I look at what's happening, git status, okay, I've got an untracked file. So it's going, oh, there's a thing here I don't know about. Do you want to put this in here? And so I can add that. So if I'm adding it, I want Git to start tracking this file. Cool. So git status. So to say, okay, here's a new thing. You got a new file you want to do. Nothing, it's just staged for committing. It's just staged so far. So I've added it to start tracking it, but I haven't committed it to the repository. So I haven't given it a new hash in this diff chain. If I want to do that, I have to go git commit. And this is where you'll probably first panic if you haven't done much command line stuff. It's because you'll come up with this weird looking editor. Going, oh my God, what's it doing? So I didn't give it a message flag. If you look over on this Git cheat sheet, usually you can commit with a message. This is like for your tracking. So if you want to track these changes, you probably want to put a message about why you added this thing here or not. Make sense, right? So yeah, so I didn't add a message. So what it will actually do is launch an editor. So I think this one's Nano. You get these old crusty Linux editors that will pop up randomly depending on your Git config. So I think this guy's Nano. So what it wants you to do is add a message. This is what it's prompting me to do. So I can go, I added hello. Okay. And I want to write that. Control X. Oh. And do you want it? So I'm trying to exit. It's asking me if I want to save. And I want to, yes, I want to save that. Okay, cool. Git status. Okay, so it's fine. Like there's no changes that aren't tracked, but my state of my repository now locally is different to the one that's on. Yeah, sorry, I got a thing on here. If you're deleting a file, it's to free up space, so it's not really deleted, right? No, Git is watching you and tracking everything. It's trying to catch your mistakes. It's really hard to actually delete stuff, but you can do that. I won't show you how to do that, but it's like the reason is just editing source code. So this is a tool for editing source code. So you shouldn't be filling up your hard drive with text files that you've written by hand. That's pretty hard to do. Okay, so I've made a commit locally to my thing. So I can go git k. This is one of these little visual tools that make it easy to see. If I do git, sorry, I should do git log. This was one of these things that said in the cheat sheet. If you want to see all the commits that have happened, you can see it's added this funny hash. Oh, sorry, can't drive my mouse. It's added this funny hash on Paul's test branch. Paul Billette did it. That's my email. If you want to spam me with email. I had it hello on Monday, the 15th of August at 5:13. Back over here, Yoni's been doing some stuff. So that's what's different between mine and here. Okay. So now, if I want this to end up on, so if we look on GitHub, let's try this. I click stop sharing. If I go programming course with Julia, should see Paul's test branch. Branch is 8 commits behind. Nothing's happened over here. So there's no message by me. We can look at the commits. If you click on commits, it will say, you only did some stuff, you only did this bonus points, big homework stuff. Nothing by me. This stuff I just did only lives on my computer. So if I want this to go to the remote, git push. Now I'm on a branch, so this is safe. This doesn't matter, but it's just a stupid little text file that says hello anyway. Even if that ends up in my notes, hopefully that doesn't crash the course and can't see the notes anymore. So depending on how you've set up Git, hopefully you've done your SSH token stuff. I can't really demo how to set that up, unfortunately. If you want a hand in person, I'm happy to do that. It's kind of hard to do as a lecture because I'll give everyone my password because I'm an idiot. Yeah, so I pushed it remotely. If we go back to GitHub, if I refresh, oh, there we go. I did a thing. Now, there's a problem with this, and I think this is probably getting a bit too far ahead from where I want to go with you guys, is git pull minus. So I'm on a sync with the remote, and stuff's been happening on the remote. This is the problem you're having with working with other people. I'm basically only working with Andy and Yoni. They're both pushing, and some of the tutors, they're pushing like typos and stuff to the homework. They've been doing stuff on the main branch. I did it a week ago. So if we look, hopefully you'll see this. Oh no, main. Oh no, because I'm on this branch, but let's close that. So if we go git checkout, I'm going to switch branches. So to switch from Paul's test branch to main, git checkout main. You see your branch is behind origin main by 8 commits and can be fast forwarded. So again, it gives you instructions. It's pretty friendly. The -- rebase puts local commits onto the end. It's kind of like a muscle memory for me. I always do it. So you can read up exactly about what the details of that are, but you'll see that some of the stuff about the project's changed. This is a Julia repo, so it's got a manifest and a project toml. Some consultation IPython notebooks, some changes to the big homework, some changes to lecture 4 and lecture 5. Make courses changed. So you get to get all these changes. These are the counts of how many things have been added, how many things have been removed. Hopefully. So, whoa. not too much. There's Andy Ferris's consult scraps. So I'll just do this one just because I can. So git checkout false test branch. We'll go back to this guy. Right, it's origin, blah. So this is one of these things where you're going to get merge. Have you been using Git with your partner or anybody yet? Or have you got merge conflicts? Is it?
And the same text box.
Yeah. So that's the normal painful thing of doing Git. This pattern of doing a branch and merging back into main is kind of trying to avoid that, but you still, if too much changes on master, you're always going to have this problem. So it's not mine's sort of quarantined to a bit, but I want to rebase origin master. So what I'm going to do is take my branch and put it onto the end of origin main, sorry. Not master, that's the thing I was saying last week. So I've got they've been doing stuff on master. I'm over here, I've made my one goofy little change. I want to take my change and pop it onto the end of the thing. So it's easier to merge back in and I'm not going to have these merge conflicts. So, cool, done. Maybe not so obvious, but I'm back onto, I added hello onto typo fixes. And yeah, push -F. Okay. Maybe this isn't a great demo, but you'll see I've made it so I can do this. Okay, cool. Now all the typo fixes and stuff come in under the stuff that Andy just did comes in underneath. Cool. Maybe not the best demo. Now, this is where if you're keeping it synced with the remote mechanism for doing this, you can do this all via the command line, but now because you're beginners, maybe some of you will be experts, do it via the API. You can make a pull request. Kind of don't want to do this, but so I want to take a particular branch. Maybe this is too small to see. So I want to merge it into main, false test branch. Okay. This is a mechanism I'd sort of recommend you to do with your partner for your homework, is if you've got a good special main branch and you make a little branch off that, rebase it, merge a pull request in, because this is how development works basically. Everywhere, this pattern, the earlier you use it and get comfortable with it, it's a good idea. So what I can do is I can make this pull request. I'm scared. I won't actually click the button to make it because Yoni will probably merge it and that text file will end up. So I won't do that. But when you do, this little thing gets merged back in. You can, when you make this, GitHub gives you opportunities to comment on the codes. You can go like, why are you doing this? That looks silly. Why did you add this file called hello? Don't do that. You can refuse it, depending on how you set permissions up for your repository. This is kind of the normal pattern. That's fine. Okay, I will go away from this though. I'm going to cancel that. Oh, that's annoying. Zoom's decided to sit over my thing. So, okay. You can tell that I'm an open source vampire. I don't actually contribute much. I've just got a couple of little goofy things I've done here. I don't get enough time. I totally recommend, you know, if you get into this programming thing, it's a really good way to learn. You can learn with some super talented people and you'll learn really quickly if you get involved in open source development. When I was younger, maybe, not now. I'm too time poor to do anything. I can barely keep up, but yeah, so you get some crazy things. So a friend of mine who got really big into open source development, he's friends with someone who's won an Academy Award for special effects, because when he was doing his PhD, he got really bored, decided to do computer graphics instead, contributed to open source projects and ended up making that strange connection. So it's kind of weird. Ends up being a really small world. Okay, so I hope that's clear. Making a repository via GitHub's pretty easy. Viewing the history. So this one's one of mine. I just made for the course last year. So cd source. This one's less scary. So git k. If I'd pulled the button, if I'd pushed the button before, what you should have seen is like made a couple of little commits, merge back into master. You'll see these little loops. So that's the pattern you sort of want to go for. You make a branch, commit a few changes, do a pull request back onto master after rebasing, comes back in. That's where I want you to be using this stuff. It's a little bit hard. If it's just two, honestly though, if it's just two people, you can just commit to main. Just make sure you're always pulling and rebasing and then committing, keep it up to date. Biggest problem people have with Git is branches that go for too long. And then they become impossible to get back onto the main. So like this is I've seen this in professional career, it happens all the time. It gets to such a state that the merge conflicts that you get when you try and put it back in are too out of control to deal with it. So just keep it, if you're going to do a little branch, it's like a short-lived thing. That's my one bit of advice. You know, don't let them go for too long because the two bits will go away. Cool. That's Git. Little demo. Hopefully that's useful. Just push on to main. Just push on to main. It's fine. Okay. Cool. All right. That's that. Okay. What do we want to go with this? Okay. We'll go back to the notes. Hopefully I didn't miss anything. Is anyone using GitLab or did everyone go GitHub? GitHub as a ubiquitous solution now? Yeah, fair enough. Yeah, there's other version control systems. You know, every bit of advice I give you might change in 5 years. This is like, software moves pretty quickly. Just because it's popular now doesn't mean it's popular in the future. One of these things that gets about code organization is like, you think of a very large software organization, how do they organize their code? Like, how do you even navigate a big, so like, I think, like I've said, like I'm going to talk about Linux and Unix. I think that's 30 million lines of code. Maybe it's something of the order of that. This thing I'm using, Firefox web browser, they're huge projects. Like, how do you actually organize code for these giant things? Can do it as one giant repository. They call it a mono repo. You can do lots of little repositories, and then you've got to try and join everything together. This stuff is not a solved problem, and it's changing all the time. Yeah, different, like the ideas come out of these big organizations about maybe this is the best way to do it. But again, if you're just doing homework, maybe it's not the best tool for you. Saying a lot. Okay. Okay, so, okay, Unix. I'll just say a tiny bit about this. You would have seen me doing some bash scripting, bash stuff. Who's used command line before, just quickly, or who hasn't? Which way's smaller number? A couple of people haven't used command line? Yep, that's fine. Anyone on the chat? It's pretty straightforward. Like when I started using computers as a kid, it was DOS. That's all you got. So it's kind of more familiar to me. But if you've grown up with visual systems, it's kind of like, oh, this is weird. Why would you even do this? I understand that. Even this thing of like, what's an operating system? What's that for? And like you get, it's not like, sort of coming the way that everything's like what you'd think of as a computer, a personal computer. I had a friend who worked on these kind of things, smartwatch type things. And they're basically just Android with a skin on the top. That's like, so it's a little operating system. Back not so long ago, you'd have a microcontroller where it doesn't have the whole overhead of an operating system and things you'd want to do on an operating system, like run multiple processes at the same time and be able to switch between them. You know, if you're just doing one thing, just do one thing. It's much simpler. One of the things where that comes in, like one of the last places it stays, which I find really kind of interesting, is in music. So if any of you are into music and recording electronic music, is that real-time operating systems are required. So the types of operating systems like Windows and Linux are kind of getting slower over time in terms of responsiveness. So if you're making like a drum machine or something, you kind of want it to be really fast. You don't want it to be waiting and this latency or jitter in timing. So They'll use microcontrollers or real-time operating systems, which are very different. Nothing to do with anything, but just this idea that, you know, not everything's a computer like this. There's some other weird things that are still computers. Basically, you're trying to manage, the operating system's trying to manage software and hardware, user interacting with this stuff and calls to the CPU. So you're going to have files, RAM, programs that are running, processes, threads. I won't say too much about all that. Dealing with input and output, networking, connecting to the internet, all this sort of stuff. So low-level interface between running programs and hardware and its own programs, managing the system. So what we're really doing is interacting with the shell. So they call the inside bit a kernel because it's like a nut in the middle, and then you've got a shell around the outside. That's this little bit of jargon. So bash, maybe I've said bash. That's what this program is. I keep doing over here. I'm running a terminal, running bash commands. Bash is born again shell, is the acronym, BASH. A shell is for interacting with the kernel. So, okay, so back in the day, I think that's a useful picture to show. There's definitely this plot I want to show you guys. No, it's not here. Okay. So Unix is the old grandfather of all these things. For if you want to use multiple users on one computer doing multiple tasks at the same time, that's like a really normal thing now. But back in the 60s, you know, it's kind of like a new idea. The big thing with Unix was they wanted it to be portable. So usually, I said about these hierarchy of language levels. So like you've got assembly down the bottom, and assembly is specific to a particular CPU. Then you've got compiled programs that compile down to assembly, C being one of the earlier ones, still around. If you want to have this thing that you can, so you want to be able to take this thing from one computer to another computer to another computer. So back when mainframes were the day, so like that wasn't super obvious that you'd want to do that. It's kind of super obvious now that, you know, an operating system that only works for that CPU is kind of stupid. Unix was the one. It was made at AT&T Labs. AT&T Labs has a fascinating history of this time. It was a giant, it's like one of these giant tech companies now. So like Google and that, they were the American telephone something or other, AT&T. They had a monopoly on the telephone network in America. So they had a giant amount of money, a big pile of money, and they had a giant, amazing research institute. And they came up with lots and lots of amazing things. Had lots of Nobel Prize winners there. Claude Shannon worked there, information theory, pretty famous. The inventors of the C language. So we've got Ken Thompson, Dennis Ritchie, all sorts of things. Cool, so that's the grandfather. And it's a really, it's still used. So Mac OS is based on Unix, a port of Unix. I wanted to get, maybe it's the operating system one. There's like a family tree. I think I had this in the notes. I'm gonna get sad if I can't find it. Yeah, that's the plot I wanted. So it's going backwards in time to the whole zoo of Unix-like operating systems that we have today. You can go through that. So there's all these kind of, so Unix was proprietary. I'll talk about licensing in a little bit. It was at this commercial place. And then eventually they split off into BSD, and that still exists, BSD to today, free BSD. So open source implementation of this, still around. Then we got, yeah, a whole bunch of crazy stuff. Linux starting back here. So Minix is another one. So this one is bizarre because I think, I'm going to say this and it's probably not going to be true, but like every computer has a version of Unix on it, on the CPU. Minix is Intel for, so all the Intel ones anyway. I think Intel give Minix on the CPUs to do something bizarre. So like, I don't know exactly what it's there for, but I heard recently that it was there. Linux started with Linus Torvalds. He's the inventor of Git. So he did this as like a master's project or something. He just wanted to make an operating system as an example, and it sort of got out of control, as you do. Julia was a PhD project, so that got out of control as well. So stuff happens. It's kind of interesting. Mac OS is split off Unix, as I said. So like it's got a terminal. Windows is kind of something else. So maybe you're more familiar with that. It's not Unix based. It was its own thing. It's got its own provenance. No, in between. So it's the thing that's dealing with input, output, and passing processes to the CPU and managing what's running on the computer. The central processing unit. So the thing that's like this logic circuits, all these little logic circuits that are doing the calculations really fast. Yeah. Okay. So, yeah, I feel like I did a bad explanation of that, but that's okay. You get an idea. Go and read up about stuff. But so this thing of having a terminal, so it's called a terminal because it's like you used to have a little screen, and if you wanted, you had a multi-user process. You know, you wanted your time sharing on a big mainframe computer, so it's like a big supercomputer of the day, and different users would log in and use it at the same time, and they had their own little terminal. This is a terminal, and I'm running Bash. Bash is a program. Bash is a little bit weird. Bash is itself a programming language, and it is a Turing complete programming language, I believe. You can do a lot, but it's also lets you run lots of other little programs. Everything I'm doing here, so I said something like ls. Ls is, these are Bash commands, runs a program. Ls is a program, and it lists what's in the current directory. So if you want a little bit of help, usually the pattern for these programs is you do the program. So the interface for these programs is you go ls -- help if you want it to tell you what to do. So that's a big help file. So there's all this sort of stuff you're going to do that I never do. Ignores, adding, blah, 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 blah. There's basically a pattern to this thing. So Bash isn't a standard. That's one of these things I want to say. I'll go to that in a bit of time. But there's a typical set of things you'd want to be able to do. List the current directory, navigate around. So we'll just start with that. So key navigation commands, as I said, ls for listing what's in the current directory, cd for change directory. So this is ancient. That's why it's all two-letter things. You know, you probably had a actual memory requirement for how big these things would have been when they got written because they're so old. Change directory. So I've got a directory here called data. Now I'm in data. ls, there's something else in there. Yeah, so the other useful one for you is pwd, which is print working directory. So home, bullet source, call silly test repo / data. Again, see if this one works. Yeah, all of them give you help, and they'll have extra options if you want to do extra things. It's really about chaining commands together. That's what Bash is all about. So talked about this into more. So really what you want to do is, the really powerful thing about Bash is it provides a simple way to interact with the kernel to do task automation. So if you want to do a thing, pass it to another thing, pass it to another thing, pass it to another thing, done. That's really what Bash is about. I think I've shown you some of these before, so let's go from, you can make a directory, test. So now if I go ls, I should see test. Okay, so there's a couple of little dotty dashy things that will probably be useful for you to see as well. So I can move something. MV stands for move. / source. I'm sorry, data tab, this guy to here. So what this little magic spell, hopefully you can see that. I'm going to move a directory down, 2 dots for directory down, into data, get this JPEG, move it to here. Now if I ls, it's here. If I go cd /data, it's gone, which is kind of annoying. So what I can do is copy. If I don't want to move the file, I can copy the file. cd // what do I call it? Test to here. ls. So now it's back. Cool. And hopefully Git's not confused. So this is a Git repo, remember? Just linking back to the last thing I was saying about. So hopefully Git's recognized that I moved this thing out, moved it back again. It's the same thing, and it's not going to be upset with me. It's going, oh, that's fine. You just added this thing called test. Good. ls. If I want to remove a file, I can. I can also remove the directory. Oh, directory is not empty, so I can't do that. So it's kind of helpful. So cd test ls, I can remove a particular file. And then remove the directory. And everything's back as it was. That's a little bunch of commands. They're the basic navigation commands. Hopefully that's not too dumb. You could probably work that out yourself, but helpful to go through it sometimes, I guess. Okay, so that's the basic bash stuff. Okay, there's a few more useful things. I've got a list here. These will come up. Echo. I showed you this one a second ago when I made hello. I also showed you piping it into a file. Echo hello. It says hello. This one's obvious. Now this one, I don't know, maybe this is just a dad joke, but you know how I said you can always do -- help? Echo is the only special one. So you go echo help and it says help. So it's like your best friend when you're in trouble. It just says help too. It doesn't help you. If you want to get the help for echo, you go man for manual and you'll get a description. If you actually want the help for echo. Some of these command line programs, you go man, but some of them are -- help. This is just one for help. And I just thought I'd show you that so you know that. And press Q to quit. So I just think it's funny because I got a bad sense of humor. Okay, so other ones that are useful. Let's go here. So we got source. I don't think I have a really, cat will print out what's in a text file, depending on how big the text file is. Cool. That just prints out whatever's in the text file. That's a small one. I'm trying to find a big one. IDIM integration. Can't spell. Okay, so that's a big mess. So that's a Julia program that does a bunch of stuff. If you don't want the whole thing, so a really useful thing when you've just like downloaded a file and you just want to see what's in the thing, you go head. Oh, sorry, that got confused. And it will just print out the first 10 lines of the function of the text file. So yeah, so if you want the last, you go tail. That gives you the bottom 10 lines. So really useful if you've just got like a log file from a running program. This is like the super useful one is you tail the log. You can see what's happening as it's going. That's really useful. Okay. Okay. So I was going to demo Diff. So if I have cat intro.text, it was a dark and stormy night. Intro 2, it was a dark and stormy night, blah, 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 blah. Diff is basically what Git is built on. So it goes through 2 text files line by line and tells you the differences between them, which is really useful. So diff intro text. So bit of a magic spell, but it will give you that this guy is present in one, and the correct spelling, night, and this extra stuff is present in the other one. So hopefully you can see that. So it was a dark and stormy typo. It was a dark and stormy night plus this stuff. So the differences are the first file has this, the second file has these two. Part of the reason Git's merging is terrible is because it's dumb. Like it's just going through the files line by line like this, and you can't tell that, you know, what do I actually mean? And exercise for you guys to think about is implementing differencing between two text files in a semantic way. It's not easy, right? Like differencing, oh, these strings are different. Yeah, not too bad, but differencing in a way where you can catch, like I've just inserted a line here and everything else is the same, rather than saying it's the same up to this point and then everything else is different. It's just that there's one edit in the middle. Think about how you might go about implementing a diff algorithm. It's not straightforward. Hopefully you see that that's kind of it. Git merging is bad because diffing isn't super simple. It's easy to do something simple, and that's what they've done. They're line numbers, sorry for that. What are these funny little 8C, 7? That's which line number they come into. 1, 2, 3, 4, 5, 6, 7, and 8. grep is for searching within a text file. So really useful tool. I won't say too much about that, but you'll use it. Vim. Okay, we'll get onto editors now. So I was doing cat, and that's kind of awful. Next up is you might want to look at a file and start dealing with it like a person. An old school one, old school, I get in trouble for saying that, is Vim. Before in my commit message, you would have seen nano come up. This is an old, it's not that old, but it's a text editor. Vim is one of these options that you might use for your Git commits. Anyone use Vim before? Yeah, it's like, can be hilarious to the first time you use it because it's like a modal text editor. If I try and type, something weird happened. Something disappeared. Escape, quit. Oh no, escape, quit, because it's really intuitive. It's one of these tools like Git where there's a bunch of magic spells. So I'm going to quit, not write anything. Vim, if I want to start typing stuff, I shift I, and then I go into edit mode. And then you can go and change stuff. So I can delete this, escape, right. And now I'm into the other mode where I'm starting to do things. So that writes that out. You can do select whole lines though, and then there's a whole bunch of stuff you can do. People who are good at Vim get really, there's a lot of customization. Again, I have a friend who's like a Vim demon, and he doesn't do too many presses on the buttons, but a lot of stuff happens. So you can get really, really good at using Vim. I used Vim for years. I didn't use IDEs, but that's the next section. So a couple of minutes for questions, then I'll start talking about VS Code and that, because I think that's a nice lead in. Or maybe a few more little commands. So stuff you'll see is chmod, change modifications, who I am. Sudo is to like escalate your privileges if you want to do something to the system. Super user do. That lets you delete your own hard drive if you want to. Top is another really useful one. I would have shown you this before. Top is what's running on my computer now. So you'll see here, Zoom is thrashing, Xorg's doing something, some audio things doing something, and then a whole bunch of other stuff. This one, super useful when you're actually programming at the top. These PIDs, like if you've got something going out of control and you want to kill it, I think that was a question a couple of weeks ago, like what do I do? If you're in the program and you want to kill it, like Julia, you're running it, you want to stop, Control C. If you've set off a process and it's gone rogue, you can go find its PID and kill it. So like kill it good, so it'll definitely stop. Another useful one. PS to see running processes. Bash is running. and PS. So that's kind of boring. It's like the only two things running at the moment are bash and PS itself. These guys, we would have seen these in the notes. Curl wget SSH is to run a shell on another computer. It uses cryptography, super useful one. This one's great. I use this like every day. If I want to have a terminal on a remote server, I use SSH. So it lets you log on and use a terminal. Like internet's built on this stuff. And development tools, GCC. Okay, I wanted a tiny demo. This is, so we would have said in the notes, Julia, you can do all this stuff in Julia too. So when you start a Julia session, it lets you, if you press semicolon, it gives you a shell mode. So I can do ls. Cool. It's just the same as before. All these things make the work. Oh, file exists. I can't make the thing. Oh, well. Anyway, you get the point. What I wanted to show you though, this might be lost on you, but we'll just try. Okay, this is just a demo that bash isn't bash. Bash is an implementation of a shell. There's no kind of standard for a shell. If you see this funny little syntax here, I'm going echo, so it should just repeat what I'm doing. And this is a little useful bit of bash scripting stuff. What it will do, you should be able to see, is it will go through this inner curly braces list and fill them in. So it'll go ABE, ACE, ADE. Kind of useful. You could imagine if you've got a bunch of file names and you want to just iterate over the last one, you could do something like that. This depends on the implementation, whether this is supported or not. If I go into Julia's shell, and hopefully this hasn't changed between Julia versions, because this always used to be true, that doesn't work. So that's not implemented in the Julia shell, but it is implemented in bash. A shell is not a standard. They're all kind of a little bit different, and you have to learn the quirks of each one. So when you're on Windows and you're using PowerShell or you're using Git Bash, you don't necessarily get all the features you'd get on bash as implemented in Linux. Okay. I'll take a break there, then we'll talk about editors, if that's fine. Cool.
Using it
Yeah,
like puts you into the.
We'll start working on not
So it just uses its own shell.
you can go to this.
Oh wait, I'm on this.
That's like it's not a like old school of what people do now. So use Python or something like Julia as a shell. Do all this, you know, like you can form programs you can do it and stuff. So like if you're more kind of box, like depends on you this is there. Depends on what you're trying to do. So like you've got this problem of like you've been making sure your progress and how do you run? How do you run? Say it's like say like you do something like every day, download the start. You could either add really the moment forever. So typically what you do is the bash start with content, which is like add time, should this thing. So again, so it would basically be a change in the bash thing. Yeah, it's like a lot of something. It's easy to learn without change the yeah.
I feel like just so they might use or you can do so like if you're going the first aspect of first yeah then if you're which okay then that one's very useful if you got it. So you see, like, so here's my friends. Control yes, it says your message not going to see things that it's not interesting. Yeah, you can cycle through all these. Let's see, we ran through it and look at it and try to do it. No, it's like I guess it doesn't really matter if you put it itself, like it still just treats it like it's another part of it. Yeah. So this is like kind of more so like and this one I don't know if I got on this guy. So parallel. So this is from the command line. If you wanted to run actual your version in parallel or 150, you can do that. Like so, like if you've got a bit of data process, like a bit of you can think about how to make a program split into n copies. Do work independently. We can make it in faster. Yeah. This is my day job. Is today was diving by getting straight. So correct number. 128 times 8 process and get to the results. But that's on the moment. Running a whole bunch of servers, running over you can see clearly the amendments. No, you have got to share instance. If you can use the website, start up a server, take into them, start the process. You rent computer file. Okay, so that's another different things. It's been implemented the game through it's good for stuff like it's just playing the yeah. So that was a big impact like yeah, that's like it's just a process. Yeah. Yeah, I wanted to the Unix version of the I don't know, pretty easy. I just Google but this feels like pretty
I can see why they do it. It's still going to be changing. I guess for them, you can also actually do something. But it's still learning about yeah, because when you sort of using this to arrange files and something, maybe how do you first program the means never is on this to do then we'll do some that's for a little easy to use that implementation or right.
Yeah, it's different things. Every server from yeah, there is the old little this is one I said.
They're only using exactly the same.
We know this. Yeah. Yeah, it's exactly the same. You want to do all this is working on the volume. You don't want to push the button. In this day, you
Bills. It's great. Yeah, and you know, when I mean, I don't instead of yeah, but it's still actually, I mean, yeah, but it feels like you're interacting directly with, I mean, you know, I'm still like, yeah, but it feels more like,
yeah, I can show you a solution I've got. So, I don't have that one on this computer. You can launch like 16 channels.
Yeah. Still very scary.
Yeah.
I guess that's what ARM is.
This is like that one typical. I do that one.
I mean, nice.
Do kind of the same thing on everyone.
Is there a simple way to flatten
Regions, we used to be able to do is find
I do have a gross miscomprehension. It only works in practice.
You can
I'm trying to build a.
So 1, 2, 3. So like you mean like a matrix? Video, right? Or we can do that. That's kind of dirty.
Yeah, that actually would be good. Dictionary.
Oh, the dictionary.
Yeah.
Oh, is this for the
Yeah, I was trying to not do it. I have a poll with which works, but I'm not. That's a question. I can comment. I have. Oh, sorry. I had it as a hard comprehension. Yeah. This is my but it's because X here is still an array. It's a array containing grades. We need a way to flatten it out. It's just an array.
I have to see your exact problem.
Yeah.
So you get like you can do a comprehension on a dictionary. You can go like so you can do like you can do that kind of thing. I don't know if that's helpful for you. Yeah, it's probably if it's nested deeply, it's going to be.
But I'm not finance. I think I'm going to waste my time. I was up till 3:30 in the morning doing the last one because I got the time down, but then it kept crashing my laptop because it was using 11 gigabytes. Wow. And so I managed to get it down to 9 megabytes.
Yep.
But then I went the other way. Now it takes 2 minutes. So I'm really frustrated. Well, I think the two minutes is sufficient. It's sufficient, right?
Yeah, it's just like a reasonable, like my problems with this.
Yeah.
Like your computer will have a market.
Yes. Okay. Well, that's okay. Like I'm sort of moved on it now because I know that it's good.
Yeah. Especially rather than
yeah. Well, I only come back in like this because I know like yeah, I think it's like crash my computer. Yeah. We can reach crash it.
So what I do that one question right? So that's the past but I just wanted to know if to initialize these without having to because I think it's just like a little bit of kind of like see what I haven't here is that when I did jails, I just extended the I just want to just yeah. Yeah, something. So I need to. In that question, what is the actual? It doesn't really say anything like deviate from the sort of blades, shapes.
Yeah. So it's typically the heart of
Yeah. Is it just based on the size of like
the one? There's a bit of difference. But it should be conservative.
yeah, so it should just be close to so is it better being further away from zero, something that's like bigger than the additional?
Yeah, so it should be comfortable. But now it's not really yeah, generally like accuracy. This is like you know, compare everything or part of the resolution
and like I'm just I just feel I'm trying to switch it into my shit. I'm like right.
Should be trying
yeah, I mean I've been very aesthetic.
I
mean, we need to like there's question about
Yeah. But I want to
question or something on that. Is it just like does it work?
I'm not so sure about if it's even useful or
I did one line. Yeah, this counts how many times the word task should have. Yeah, that's what Flatness is that you've already installed Flatness. I don't know how else to do it. So that works. Yeah, that makes sense. So how do you sort of string strings?
How do you do what?
We got string.
I think there's a long. I think there is a long.
Oh, it is lowercase. So okay.
All right, back to it. Okay. What am I up to? Okay, so Bash is cool. Hopefully you can see how useful it is. I didn't say anything about Bash scripts. I think I've got one here. I don't have one here, but oh yeah, I do. Test. Okay, so let's go this guy. Let's see. Okay. This is horrible to look at. Let's look at it in Vim. Okay. So I didn't really say about Bash scripting. This is the way it starts to get more and more useful, is you want to chain these things together. So I can make a little thing called a Bash script. This lets me run it. This is called a shebang at the front. Make the test, cd into test, file names output, run Julia, hello.julia, pipe it into a file name. Echo, I write a file called file name. So that's a variable, file name. I'm changing it here. I could have this as a thing that comes in. I can actually start making this like a little program where I can take a variable in or to automate all this stuff. So this is just an example. You guys can go look on my repo. If you look up me up on GitHub, you'll see where this is, but you can try running this thing. So this will, again, this is where Bash starts to get really, really powerful, is you can chain these things one after the other and do useful things, hopefully. So like, I'm gonna make a directory called test, cd into it, set file name, do Julia, echo saying I wrote a file called file. Quit. Oh, no, it's not there. Oh, sorry. It's not right. Oh, there's this one called test. So this is a really bad program. So cd test, ls, rm output.text, render test. Let's try it again. So not a bit of a buggy Bash script, but if I go run test sheet, it'll go through and say I wrote a file called output.text, ls. If I go into test, in output.text, hello from Julia. So back to this guy. So there's a program 2 directories down called hello Julia. I'm going to pipe it into this file and say what I wrote. That's the kind of thing you can do. So there should be hello.julia, which is just print line hello from Julia. So this is the kind of, you can start to think of it like it's another little programming language that you can do lots of things. Sometimes it's easier to do it in Bash. Sometimes it's easier to just start Julia and do everything inside Julia. This is kind of the way it's gone. Before languages like Python and Julia were around as scripting type languages, it was really common. Like if you've got C programs, you don't want to be doing all this file stuff necessarily there. It's easier to do it on the outside with Bash. Nowadays, usual thing to do is the only thing in your Bash script is to start Python or to start Julia and then do everything inside there. That's kind of the way it's gone these days, but super useful to know. Okay, so Unix philosophy is actually super interesting. This is useful for if you think about how you design your little functions in Julia. So this is like, there's no science to this stuff that I know of. It's really just taste and you develop it over time, which is kind of like a really bad thing to say in a university lecture. But design goals is like, if you're going to have something that works really well, think this thing's going to like outlast religion. It's like a cockroach, Unix is. It's just like, it's, you know, it will survive the nuclear winter because this design thing, it's like, if you want to think about how to design programs, this is like a really, really good example. Not like Git. Git is like a bit hard, but Unix is like kind of nice. It's like, so you have one program, but Git is part of the Unix ecosystem. It's just its API is a bit yuck. So each program, do one thing and do it well. That's kind of what you want it to do. You have one program that does one thing well. And if you've got a new job, build afresh rather than complicate old programs by adding new features. Like this is like someone saying in the 70s that they should do this. It's like, this is like, lots of people need to learn this because it's like, it's often harder to add to a program than it is to start again. And don't be scared of starting again. I terrify people like this when I work because I tend to just rewrite things all the time. I'd encourage you to be like that. But, you know, if something works and does what you want, use it. Like learn the tools that you have available and use them. But if you need to do something else, don't be scared to rewrite stuff. Always expect the output of one program to become the input to another program that you don't necessarily know exists yet. So think about what your outputs are going to be and what's going to be useful. So what you're passing in your returns in Julia, really think about that. Like, because someone else might pick this up and use it again. That's how you get stuff that lasts. Not too much extra stuff. Don't insist on interactive input, because if you want to script this, if you have to have a program that halfway through it goes type yes or no to continue, all this bash script automation stuff won't work. You'll have to get there and press go. So don't insist that you have to be interactive. This one is huge and good idea for your homework. I'm hearing lots of you guys saying you're up to 15 and stuff already. It's like amazing. So try it early, ideally weeks, and don't throw away bad bits and rebuild them. Like iterating faster is like the magic thing for doing software. If you just try and get completeness first, so like if you're going to do your homework, just try and do every bad job of everything first and then make it good, is a really, really good way to approach these things. And this is like true for professional software too. If you have a thing that goes end to end and can do something, even if it's bad, it's much better than something that's beautiful and does nothing because it's not quite finished yet. Yep, so use tools, build tools. Software developers love building tools for themselves. Git was made by Linus when he was making Linux because he found it hard to share code. Back in those days, it was emailing patches to each other. That's what Git was built on, so it's a relic of its time. But he stopped, you know, here's this thing I need because it will make my life easier. Build a tool to make your life easier. If you keep building enough of those things, you can just, and they're simple, you can chain them together and you'll get something that's better than you thought it would be at the start. Things compose and get better in a sort of multiplicative way rather than an additive way, if they're simple. That's like wisdom stuff that's kind of like, if you're a beginner, it's like, whatever, shut up, Paul. But yeah, when you're older, you go, yeah, that's true. I wish I did that, but I don't. I still keep doing terrible things. Okay, so an IDE. Everyone is using VS Code, I assume. Anyone being weird and doing something strange? No one? Everyone's going VS Code? Fair enough. I would too. I do. So as I was saying, source code, Julia files are just text files. So a text file editor is sufficient to do software development. If you get a text editor with a few more extra things like Vim, you can be quite productive and it's a good way to develop. The longest time I just used Vim, like Vim and whatever else, that was enough. Now I started using VS Code because everyone else does, so that's a good sign that it's better. Again, like thinking about desired features of a thing, you want to be able to edit text is like the fundamental thing. It's like what you're doing when you're writing code is you're just editing text. It's like, so a thing that lets you edit text is kind of essential. Source code navigation is super important. So like when you get to a big, not so bad for you guys now, you're just doing notebooks and stuff, and you'll have a file hierarchy with a bunch of stuff in there. It's not too hard to navigate around. You get to a big code base, this bit becomes really difficult. So being able to search through the code base, find the thing you want. Again, it's not that bad if you've got the Unix things. I just used to use grep all the time. So like that's the way of searching for strings in a file. It's like you can just use grep and vim and get a long way. Source code navigation, though, is useful. Syntax highlighting is really more useful than I ever would have thought. Like just being able to see, like if you look, I think I've got a Julia thing in this, so that's not the best example. But looking in VS Code, just being able to tell all this stuff, that this is a function, there's some variables, there's a bit of syntax highlighting. When you're trying to look for stuff that's going wrong, it's super, super useful. In terms of source code navigation, all of you guys will be familiar with this stuff. You can search for things over here. This will be a useless one because it'll find a million things. You can search and replace over in the files. You can search and replace lower rank. So no matches. You get these string matching options. So if I care about case or I care about matching the whole word, if I don't care about matching the whole word, you know, you're just going like, oh, I knew I called it low rank something or other. It's low rank of procs. Then you can go, oh yeah, there's all the instances of that. If you want to read, that's super useful. Maybe not so useful. Is anyone using a debugger for Julia? Yeah, no, sometimes. I don't use a debugger myself because I find them a bit annoying, but sometimes they're really good. With Python, it's good with interpreted stuff. I don't think the Julia debugger story is great at the moment. Code completion, depending on your language, this can be fantastic. Like a lot of lower level languages like C, or Java is the one I'm going to think about, is like, there's a lot of what they call boilerplate. Is that a term anyone's heard of before? You have. No one else? Do you imagine like the plate on a boiler that says like, this is how powerful it is. This is when it was made. It's got these operating conditions. It's just like boring, useful information that you need to do. They say boilerplate code is just like repetitive stuff that you need to do to get the program to work. Languages like Julia and Python, no, it's not so much boilerplate, but if you're doing something like Java, the setup is enormous. So being to, like I was just saying to the guy before, is like pressing tab and having things pop up and go like, oh, do you mean this? Importing a class if you want that. Code completion is very, very useful. Integrated version control. This is built in. So you'll notice over here, I've got this little Git icon. It's like, oh, I've edited things. So all this stuff, if you don't want to necessarily deal with the command line stuff of Git, you've got it built into your editor. So I can look here and it's gone, oh, you've changed good to good. Maybe I don't want to do that. I discard that change. Are you sure? Discard. Output text.change. Discard changes. Okay, cool. Then you can sync. You've got your little buttons. You can click away. If you want to click and not drive the command line, you can do it via your editor. Don't necessarily recommend it because sometimes this is probably more advanced than where you guys are at, but how it decides you want to do a merge. One of these Git magic spells is what it decides when you click the button. Sometimes that's a good thing, sometimes it's a bad thing. Cool. So getting all this stuff in there is a good thing. Okay. Language support and code linting. Linting is like a dumb thing you can do to check whether your program looks crazy or not. It's just like, how wide is it? Did you do a one-line function that's 400 characters long? I'm not looking at anyone. If you run a linter over a program, it will go, no, you did too many characters wide. That's going to be hard to read. You need to put a new line in and break it over so people can actually read it. That's what linting is. Recommend using VS Code. Made by Microsoft. Yeah, why not? I like it. So you guys would have seen the extensions of really what make it useful. So this computer I don't actually use for development. It's just one I had hanging around the house. I use a spell checker because I can't spell. Docker is a way of managing. Docker is like, you can think of it like a little VM, a virtual machine. You can make a little Linux distribution inside a container. Everything is built the way you want it to be. That's the thing called Docker. I use that a lot. Hex Editor, that was just for this course. JavaScript and TypeScript. Julia. So hopefully you've all installed this guy. Have you all installed the Julia extension for VS Code? Cool. Jupyter, some Markdown stuff, some Python stuff. That's just for this computer. Cool. That's straightforward. That's what an editor is. Integrated development environment. They get very sophisticated. Like the ones you pay for are quite amazing. Like there's features here like who's used Copilot for? Is that one people have seen? Do you even know that? It's an AI assisted completer. So it has looked over like all the GitHub repos and it has a neural network that's learned how to write code for you. So it will start finishing. Going back to the beginning, it will actually do the Quake 3 algorithm. If you start typing it in C, it will finish it for you. Copilot, GitHub Copilot. I haven't actually used it for real. I've just tried it out for fun. But if it's repetitive code, like that's super useful. And maybe that's where programming languages go in the future. It's a person talking to a very clever autocomplete. That'd be awesome. I think that's great. Try it out. Okay, last one I wanted to finish on, and then we'll get started on section 3, is software licensing, because I get junior people and they don't know anything about software licensing, and it's slightly terrifying when you're in a commercial environment because there's consequences. So I'll just say, I'll pretty much just read this stuff, but two big classes, proprietary software and free and open source software. So proprietary software is the stuff I write at work every day. Secret, you can't find it. If you find it, I get in trouble, I lose my job. So it's closely guarded secret. Like, how does Windows work? Nobody knows. Like, that's a closely guarded secret. They have an army of lawyers descend on you if you tried to get that source code and use it for something else. So don't use it. Like, don't randomly copy code off the internet is probably where I'm trying to get at, unless people want you to. So free and open source doesn't quite mean what you think it does. It doesn't mean you can do whatever you want with it. So Julia is open source. Linux kernel is open source. Very different kettle of fish in how they can be used. So there's lots of different philosophies around why they chose to do it this way, and you've got to kind of respect it. And they do have legal consequences. Like in the past, it seemed to be more of a bigger deal that this would get cracked down on. I don't know what the state of it is. Yeah, and it's really, I'd probably frame it in terms of respect for the person who wrote it. They had a particular intention when they wrote it of how they wanted it to be used. And it's really about respecting that more than worrying about legal stuff, because that's kind of silly. The big classes are permissive licenses, which is what Julia falls onto. BSD, MIT, or Apache licenses are those ones. Copyleft, GPL. This is a kind of very ideological one. So this one's really interesting. And then there's public domain, which is like, yay, whatever, do what you want. So permissive licenses are favorable for commercial organizations. So if I want to use Julia in my secret code at work that makes lots of money for people, it's fine. I don't need to worry about that. I can use it for whatever I want in that way. Just got to maintain the license class. Copyleft is a bit different. So you're free to redistribute anything you make from a copyleft thing. So if I use Linux source code kernel code in my code, GPL is like a virus. My code's now GPL code too, with kind of funny consequences with this. It's like, this is designed by people who are super ideological about freedom. And, you know, they were idealistic people in California in the 60s and 70s. And they were like, yeah, if information's free, everything should be free, but you've got to make it free. If you use my free stuff, your stuff's free too now. So it's a bit like a virus. So GPL code is called copyleft rather than copyright because of this reason, because it's a bit unorthodox. So funny story that I won't say, it goes on YouTube, so I won't say, but there was a car manufacturer who for their entertainment system used GPL code. Hacker at home went, hey, you're using GPL code. You have to give me the source code for your all your stuff. And they did, because it's like, that's the way it goes. So using GPL code, you should have a look at, like, if you're downloading code off the internet, have a look at what its intended use is before you start using it. Academic situation for your homework doesn't matter. If you go out, do an internship and you go, hey, this software library is really awesome. check the license thing and see if it's okay with the people you're working with to use that bit of software, because they might not be happy if all their code is now out there like this as well. Maybe they will, because like support for open source is changing. It's changed a lot in my life. Microsoft runs GitHub now. It's like Microsoft hated open source like early on. It's all very different. You can run Linux on Microsoft now. So proprietary, these are examples. Microsoft Windows, Mac OS, MATLAB would be proprietary ones. Nobody really knows what goes on inside them. That's fine. Intellectual property stuff. Permissive, Julia's under an MIT license. Python's under the Python Software Foundation license. I think that's what that's acronyms for. And Android is, so this is this little bit about like what's an operating system. There's the user space and then there's the kernel. There's the bit that's doing the stuff and then there's the stuff on the outside. The outside bit is an Apache license. That's the user space, but the actual Linux bit that it's based on is for the kernel is GPL, because that was GPL, the source code they started with. Copy left, Linux, GPL v2, R is GPL v2. I don't know how that works because lots of people use R programs in commercial spaces. I don't know how that works. Maybe you just never redistribute the code and it's fine. Not my thing. And then there's some things like public domain. So linear algebra library, BLAS, SQLite's a database thing. They're the big classes. It's not like a thing I worry about day to day, but it's more like I'm saying, it's a respect thing. Like I worry about it that because it's like people who write stuff are just other people and you'll meet them. It seems like you're just getting stuff off the internet. But they're actually people and they have opinions. You should probably try and respect them. Yeah, if you're using the code, it's like there's gray areas and I'm not a lawyer to the question in the chat. So anything produced using Linux must be GPL. It's like if you're using the Linux source code to make another program, a derived work, it will become GPL as well. But you can wrap things around it and that's okay somehow. Cool. Okay, just this is a bit of a segue. So this is a little secret folder with Julia stuff in it. This is like, start getting into the command line, start hacking around and see how things work and how things are made. CD packages. Okay, all these little things. Like I've got a JSON thing here. There's a little folder inside my Julia thing that says JSON, which is one of these packages I downloaded to show you guys stuff. Whole bunch of stuff. So they end up with, after a while, you'll end up with a massive thing here. What's interesting, let's just pick one. Oh no, not a Git repository. I'm probably in the wrong spot. My demo failed. All of the, I think I've got an old, my environment's a bit messy, but all of the Julia packages are a little Git repository. I think I've just navigated to the wrong spot. So that's how the mechanism, this is how embedded all this mechanism is. So like when you package add blah, it will clone a Git repository into your Julia path and you'll be able to use that. Each one of these is a little Git repository. That's how it works. All these things is like, this is how sausages are made. There's just all these little things that get chained together. You use these little tools everywhere again and again and again to make the thing. They've decided to integrate it with Git and GitHub as well for Julia. So that's good enough. Okay. I have to find out actually where they hide that stuff. Okay, that's the end of section 2, unless anyone has any questions on that stuff. Good, move on. Okay, so unit 3. This gets to my favorite stuff about floating point and numerical methods. This is my favorite bit of, that's this sort of mathematics. That and graph theory. I love graph theory. So we're going to deal with a little bit about, this will be the end of this lecture. We'll be talking about data, some data formats. Going to talk about basic numerics. And there's lots of other courses that do numerics. Sounds like all of you guys have done a bunch of ODE stuff already, which is great. I don't have to teach you too much. I'll just try and make my little points along the way. we'll take the program on, like, this is for software development. Like, how does numerics work in a software development context? So you might have a little bit of a different opinion, might have a little bit of a different flavor about what I'd worry about versus what you'd worry about in an academic course. You're going to do more data stuff in units 6 and 7, and you'll talk a little bit about ML, which will be fun for you to learn a bit about that. It's just statistics. It's just statistics. They're rebranded statistics, but that's fine. Okay, so common data formats, CSV, JSON, and a little bit about plotting. So a file, these things on my computer that I was just looking at, I got into Julia too quick. So we've got some files, like the license. They're just a collection of bits, so with some stuff around it. So stored by your operating system on disk, and can you transfer it on the web? This is a similar one that we just wanted to echo into a file, and you can see the size of that. Okay, so text files you would have seen a lot of. That's just all the source code. You can also have binary formats. So this stuff about, like, is it a uint? Is it a float 64? You can just put these things next to each other. So there's like a uncountable number of binary formats for things. So things like a JPEG, you'd all know that from taking photos, or an MPEG. They're binary files, and they have a specific encoding. More or less difficult for different types of encoding. Some of them are really, really simple, where they'll just be, it's a text file. Like, a text file is just ASCII characters. So those bits correspond to a character, you know the spacing, so you can get each character, and there'll be special ones for a new line. You can also get random ones. So, like, we can just make a random old binary file. Let's do it. So we're going to open a file called mybinaryfile.dat in write mode. Again, always, if you're unsure what's going on, click for help. That's fine. So let's do it. Yeah, come on. That opens a thing called an IO stream. Don't worry too much about that, but it's good to hear. It'll come back again the more programming you do. Talking about streams. We're going to write into the file 1 to 20 as int8s and close the file. You could do whatever. And then make sure you close it afterwards. Okay. So we've got this mybinaryfile.dat. So if I try to cat my binary file, sorry, I can't type. It's just a bunch of nonsense. There's nothing there. So a bunch of white space. If I try and interpret this as a text file, it's like, oh yeah, of course it doesn't make sense. It was the uint, it was a bunch of int8s. So that's not a text file. So trying to interpret it as a text file doesn't make sense. You can use a program called Hex Editor on this guy, and you can see. So if you really want to, you can see what this thing is as a bunch of hex strings. Some people have a lot of fun with this stuff. So it's kind of like a fun game. The more programming you do is you get a random binary file and you got to try and work out how it's encoded. A lot of people get a lot of fun out of doing that. It's happened to me recently. I work with hyperspectral data at my work, which is a camera that can see 500 colors that humans can't see. So from visible to medium wave infrared, we have all these colors that we can see with the cameras we use at work. And they're encoded in a particular format, and they're 3D data basically. So like trying to work out how that was encoded was a fun game for me. So you'll find that it's a thing that'll come up. They're trying to decode things. Sometimes they're really dumb. They'll just be like a string of bits and you go like, oh, that's like a float 64, or maybe it's an int. Think about the data type. If it's an open standard, they'll say, oh, this binary file's in this format, and you can work out how to decode it. Really common ones though, CSV files. I am an old man. I'll try my hand at internet jokes. I find this hilarious, but maybe you don't. I don't know. Anyway, CSV, Excel is like, everyone uses Excel. Everybody corporate thing runs things on Excel. Really common data file you see is like an encoding of Excel. Excel is more powerful than it's that. But comma separated variables is typically how these things get exported. So that will be a field, comma, field. So we're going to use data frames. This is like, this type of tabular data is super, because it's so common, use data frames. Everyone use pandas in Python. Yeah, data frames is like the same thing in Julia. So let's copy some stuff across so we can just see it. So we're going to make a data frame. These are, there's a field called names, Jason, Ella, Kaylee, Emily. There's some ages, 23, 25, 13, 15. There's a gender, as a symbol, male, missing, female, female. So you're allowed to have missing data in data frames. That's part of the type. Okay, so it comes out, there's a bunch of rows, and these are the headers, names, ages, gender, blah, 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 blah. It's got, in Julia, it'll say the type. So it's a string, it's an int64, and it's a symbol with a question mark because there's this missing data value. Hopefully that's what that says. So we can use this CSV package to write a data frame out as a CSV. Cool. Alternatively, we can read this guy in. Just so you see the symmetric version of it as a data frame. I don't know why that's slow. Anyway, let's start a new tab. So we should have seen this thing, people CSV got written out. If we want to look at it, again, it's this comma separated variable. So we've got a header row, names, ages, gender, Jason as a text, male, Ella, blah, blah, blah. Missing comes in as a new line, as an empty field there, Kaylee, blah, blah, blah. Okay. All right, that worked in the background. So hopefully DF2 and DF are the same. Yeah, that's a CSV. You would have seen that. I got to make my stupid Excel joke. You can optionally have this header row or not. You get some options about whether skipping it or not. If you end up doing data science as a career, I won't say too much about that, but as a data scientist, like when you interact with businesses, they will give you CSVs, guaranteed. You went to Amy's talk, she would have said it's Excel's the devil, but it's just ubiquitous, so you got to learn to deal with it. Typically, their exports will be CSV. You get really slick at manipulating it. There's examples in the notes about doing some sort of averages and stuff. A little bit about data frames, names there. If you want to get the names, out, that will come from that header file. You can do this sort of slicing, whether you should or not. You can get the names, you can get the ages, and then you can get the gender. It's really unhappy about that one. Okay, male, yep. Cool. That's a data frame. That will come up again later on, 6 and 7. I won't say too much about that because it's boring. This one, I got a little bit of time, so I'll probably spend a bit of time on this one. So JSON is a really common format. You would have seen this as your notebooks are just JSON. It gets rendered. So the format for storing one of your Jupyter notebooks is just JSON. Yoni would have shown you this. I can go back and do it again. Where did I contribute to? Got to navigate back to this guy. Oh. Just trying to navigate back to the course. That was a really long-winded way of doing it. So practicals, Jupyter. We got a such and such an IPython notebook. If you look at it because all this stuff's pretty slick these days, if you look at it in GitHub, it will render out as all the markdown. But if we look at raw, you will see that it's this funny thing. So we've got the syntax is open bracket, and then name, and then a thing, and you're going to get, this will be this square bracket, funny square bracket, and then more of the same nested stuff inside. You can think about this as basically like a dictionary. So the Julia data type that this sort of matches to one-to-one is like a dictionary. It's like, it's going to be a key or a base data type or an array. So this one is signifying that it's an array, and these are the keys and then the values. And either it will be, the values will either be another dictionary, an array, or a base data type. And what I mean by a base data type is a float, an int, a string, or a Boolean. So this is this nested structure. This is why it's JavaScript object notation. So this will come up in Andy's section in section 4, is about, like, I sort of said a little bit about structs and like data type modeling. You can think about this as a super flexible thing of like, I can represent any old thing as a dictionary, basically. It's like, it's this hierarchy of types. What do I want to show with this? Hopefully this API is up. Should be up. So Safe Blues was a project Yoni worked on. Hope this web page is up. It's doing a GET request. So it's going to ask for data there from there. If not, we'll just go somewhere else. There we go. No, that worked. So this, okay, strand web is a GET request. So this is a response, and then we're going to get the body of this request. And that will come in as a dictionary. So this JSON maps to a dictionary. If we looked at the original text, it'd be much like what we were looking at over here, where it's going to be like curly brackets, string, semicolon, something, something, something. Problem with it being this flexible object, it's basically a dictionary, is that you kind of don't know what's inside. There might be some special layout to this thing that means something in the context of, say, if it's a Jupyter notebook, or if it's some other thing, what this object, what the data in this object, what it encodes, it's kind of missing some functions that tell you how to read it. So if you're doing the homework question, you're going like, oh, this is kind of confusing about how this layout is. It's kind of okay, that's kind of normal. If you don't have this, the schema of what these things mean inside, it can be a little bit hard to interrogate. Kind of thing you'll end up doing is you just end up digging around. I can't type. Oh, strand. Web data. And there's an R there. Okay, so that, again, your friend with doing this stuff is you go type. Because like just looking at that, it's not very helpful. And it's a vector. So that means inside strands was one of these square brackets. So there's an array of data inside there. The type of thing I would typically do for navigating this when I'm just interrogating it to try and work out what the hell's going on is I'll just get the first one. You can call first if you want to be more pedantic. And then you go, okay, it's another dictionary. Each element of this thing is another dictionary. Again, useful thing to do is type of. You can't see it. See, it's a dictionary of type string any. There's a bunch of keys in there. So there's oh, date time is the other base field I didn't mention. Yeah, so inside this thing, hopefully, if the person who designed the JSON is nice, each element in that array would be of the same kind of have the same fields. You're not guaranteed that's going to happen. I can make a dictionary with all different sorts of things inside. It's just another dictionary. So you got to be kind of careful about how you read these things and what they mean. So there's a bit of doing this sort of digging around. I hope that's useful to tell you. So back to the beginning. Strand web data, useful functions for doing this stuff is you can get keys. If you want to see what they all are without the values being there, and then dig. It's a dictionary. Like JSON can be anything removed from any more structure. You kind of have to dig around and poke around and work out what's going on. If you're trying to decode something in particular, like the use of JSON, look up the documentation for the thing that's using it. So if you're looking at a Jupyter notebook, say, and you're trying to work out what's going in there and what the structure is all about, the documentation for Jupyter notebooks would be the place to look. If that's okay. That's JSON. I don't know if you have any questions in particular about JSON. It's kind of simple. It's kind of gross though, because it's like it's too flexible. It's like have fun digging. It's like you can't get away from it. I think this is be like stuff for next time. We're up to 10 minutes too. So next we'll go into, I'll just say tomorrow we'll talk a little bit about plotting. Plotting, you can make some cool stuff. So yeah, this is like what this is intended to be. This next little bit is basic scientific work. So plotting for communication of results is super important. It's a skill you can't be too good at. Making pretty pictures. At my company, we hire people who just make pretty pictures all day because it's like it's so useful. People are visual creatures. They like to look at things and work it out. So plots package in Julia is pretty good. You can make some stuff that looks pretty cool. So it's part of your toolkit. I'm not the best at it, but we can show some stuff. And basic statistical summaries. Then we're going to get into the real bit, which is about floating point. So this is like the guts of this bit, like learning about floating point and the kind of things that go wrong is where we'll head to tomorrow. Cool. I'll call it there. If everyone happy? Okay. Thank you very much, everyone.